Okay, so I was just explaining about how test grades from last week weren't so good. Although there is quite a wide range of test grades, from like good grades to really not good grades. I decided that what would happen for this week is we're going to test not just on the second half of the chapter, which we start finishing up today. Okay, we're going to test over the whole thing. Now that means that you have less questions on the second half, and you'll also still have less questions in the first half than what you had on the previous test. But here's the key that's going to be beneficial for everyone. Okay, take the test this Thursday. If you do better on that test, that includes the first half of chapter 3, I will take that new and better grade and replace your old grade for the last test. Give you a chance to show me, yes, I really do know what I'm doing for 3-1, 3-2, 3-3. Does that sound fair?
Yes.
Okay. Gives you guys a second chance on that, because a lot of people felt really, really strapped for time, which is why I bumped the grades as a whole the way that I did, which was, plus 20% for everyone, which brought some people up to 105, 95. Quite seriously, there were some, but there were a lot of really, really low grades. Okay, that I didn't feel was acceptable for you either. So I want to give you guys this second chance in order to kind of re-earn that. And then at the end of this week, if you still don't do well on that, obviously it's not going to hurt you. Like if you score less, like if you scored 55 on the first test, and then this one that includes the whole chapter, you scored 35, I'm not going to replace the 55. Mm-hmm. I would leave that 55 alone. But this also allows you a chance to, if things don't go well on this one, you retest and you retest over the whole thing too. So you can have a chance to still improve. Trying to make sure it's fair for all of us. Okay. So tonight's homework is 3-5, which is what we were looking at the end of the last week. Okay. What we're looking at today is 3-6, but of course we reviewed 3-5 to begin with. Okay, so what we're going to be looking at today is perpendiculars and distance, but we're going to start off with some review. So first off, they give us a pair of angles and they say that they are congruent. They say that 9 and 13 are congruent. What's the relationship between 9 and 13? Helps if you're looking at 9 and 13.
Are they corresponding?
They're corresponding. They're corresponding. They're congruent. What lines are parallel as a result?
Line HI and line FG.
Okay, so I'm hearing from a couple of you. FG and HI are parallel. Oh, I did that again. Don't know why. Okay, absolutely correct. Because we're looking for which lines were parallel. Okay, we're given that these two angles are parallel this time. So if 2 and 5, that's this one and this one, are congruent, what relationship do they have? What was that?
I said the answer was A. But
You think it's A? Why did you say A?
Yeah, that doesn't even make sense.
Well, first off, I want to hear why he immediately gravitated towards there. Why not this one or this one or this one? You started ruling things out in your mind, right? And I would agree. Like, if we're dealing with these angles, we're not dealing with FG.
FG's not even on that side, so.
Yeah, and FGHI, that's not on that side either. So it's not going to be on their nose. But is it this or is it this?
No.
Why?
Because
Those aren't correct.
no, but
just tell me why.
No, I'm turning around so I can
Okay.
see. The BD, it's like sideways. You know what I'm saying? It's like a horizontal type of thing. But the CD is like a vertical type of thing. But it's not a vertical type of thing. It's a horizontal type of thing. And A.
Ronnie, none of that makes sense.
Yeah, none of it is making sense to
I
me.
already
either.
don't know it that
Angle
well, and you were
5
talking about
and
type of
angle
thing.
2 are not.
There's no
There's no
relationship.
relation, yeah.
There's no relationship.
That was literally what I was saying.
Are these, well, you were taking a long way to do it.
Understood.
So are they consecutive? No. Corresponding? No. Are they alternate interior or exterior? No. There's no relationship, so we get none.
I mean, my answer was there.
It was getting there, but we don't have all pass. on this one.
So for when you have 2 and 5, is that just because they're not like so they were parallel lines? They just weren't.
Let's
They
see.
just weren't.
These can be proven to be parallel, but not by using these angles.
Okay.
If we said,
Because like for the last one, you said they were parallel, so I was like, okay, we're
Yeah.
supposed to do this. But these were parallel. They just weren't.
well, remember we're doing these converse theorems, where it was the converse of the corresponding angle theorem, the converse of the consecutive interior angle theorem. We're saying if these are congruent and they have this relationship, then the lines are parallel. So, whereas before we said, hey, we have parallel lines, and we have this type of relationship, we can say that these are congruent. It's flipping. We have flipped so that when we have a relationship and a measure, that we prove things parallel, whereas before it was parallel, relationship proves it congruent. Or in the case of consecutive, if I have consecutive angles, if these add up to 180, that also proves things congruent because that's the converse of the consecutive angles. We doing okay?
Mm-hmm.
So, yes, these two lines are parallel, but we don't know that from this information. We can't prove it using that information. We could prove it if it was, something else.
It's just goofy.
Okay? So this one, we have none.
Right. I hate you.
Okay, so we just talked about this. If 2 and 4, if those two angles add up to 180, what postulate proves or supports that AB is parallel to CD? Well, look for the relationship. The relationship between 2 and 4 are what?
Look right next
1
to
and
each
3.
other.
Yeah, they're right next to each other, so
It's not is it consecutive interior? No.
Is like consecutive interior like the more closer inside they are? Or is
kind
it-
of. It's
so-
just if I have parallel lines, and if I have something that's crossing these parallel lines, this angle and
Yeah, those would be like the ones
yeah,
that would
like
be inside.
this one and this one
Would
are
be
consecutive.
interior.
Consecutive interior.
So that's all I was like, and what I was saying was like 2 and 4, they're inside.
Yeah, they
but
are.
They're not like.
They're consecutive interior.
Okay. Well, I was just wanting to make sure. So as long as they're not outside, they're inside.
No, they're inside. They're inside between the two parallel lines.
Okay, that makes sense.
Does that make sense?
I think so.
I'm not sure where the disconnect might be happening.
Well, okay.
Is it alternate interior? Definitely not.
No.
Is it corresponding? Definitely not. Again, they took this and they said, well, if we have two lines cut by a transversal so that they're corresponding angles, well, again, it's not corresponding. We can rule these out and go, well, they have to be that because none of the others make sense.
And it mentioned supplementary. It's the only one that mentions.
And it's the only one that measures supplement, that contains supplementary.
Oh no, it was
Just stretching?
yeah.
Okay. So how about this one? If congruent to 14? Now, people had a bit of a hard time last class on this one, kind of picturing it. Here's 5, here's 14. And they want to say that CD and HI are parallel. What postulate supports that? Well, what is the relationship between 5 and 14?
See, they're alternate interior.
So, Kawan says this one.
Can you tell me what consecutive interior? Oh, well.
We talked about that last time. If we
consecutive
have these parallel lines and they're
Mhm.
cut by transversal,
Mhm.
that this and this were consecutive interior.
Okay.
They're interior, they're supplementary, they're next to each other.
Okay.
Now,
I say
start
C.
looking at the parallel lines. We're trying to prove this is parallel to this. What's the transversal? Transversal is
wait.
this right here.
I have some pictures like
This is it. They're both inside.
Mhm.
They're on opposite sides of the transversal.
Sort of interior,
So they are alternate interior.
alternate sides, but they're still
Okay,
inside.
wait. So line C and line CD and line HI, they're not the same length. But
They don't have to be the same length to
because
be
they go
parallel.
on forever, right?
Yeah.
Okay, I'm just making sure.
Parallel just means they don't touch.
Mhm.
They're just showing segments, I will agree. We have segment CD, segment HI. They don't have to be the same length to be parallel.
Mhm.
They don't have to be the same length to be perpendicular. Okay, but because these angles are alternate interior angles, okay, they have the same measure, they're congruent, that proves that this is parallel, those two lines. Okay, this one's a bit more work, but not too bad. It says, we are trying to prove that, it says, find X, so that AB, which is this one, and HI are parallel. So those two are parallel, and we know that the measure of angle 1 is 4x plus 6, and the measure of 14 is 7x minus 27. How can I determine x?
4x plus 6 equals 7x minus 27.
4x plus 6 equals 7x minus 27. Why?
Because the 1 and the 14 are congruent.
1 and 14 are congruent because what's the relationship?
They're alternate interior.
They're alternate interior angles. So now I bring the x's together. Okay, say 6 is equal to subtract 4x, subtract 4x. Okay, bring the 27 over this side, add 27, add 27, and x is equal to 11. So we're able to do that because we know the relationship. You're mostly looking for, do I have congruent angles? Because we have alternate interior, alternate exterior corresponding. If they're consecutive interior, then they're going to be supplementary. They're going to add to 180. Okay, two lines are in the same plane and they don't intersect. What's the relationship between the lines?
Skew.
You say skew. What other choices do we have? Are they still the same or different?
Could be parallel.
You think parallel?
No, could be.
You say parallel? It's really this. What does skew mean? Skew means they're not in the same plane.
Oh, yeah.
The definition of this,
A couple of them,
skew means that we are
Different planes. Okay.
different planes.
A couple questions back, you had said, you literally just showed us that two lines, they could like
They both are on C, but they're still
Yeah, same plane,
attention.
don't touch, they have to be parallel. Okay? Same plane, because like in this case, even if I move this up here, I can still fit one plane between them,
Because it's parallel.
because it's parallel. I can still have one plane between them. Here, no. So skew means I can't fit them on one plane, but they will never intersect. Okay? So we're gonna get to something a little new today. Previously we looked at those parallel lines using the angle relationships. Now we're gonna find the distance between a point and a line, and the distance between two parallel lines. Okay, so don't forget to do your 3-5 homework tonight. This is 3-6. What we just reviewed was the 3-5 stuff. So we have very little new vocabulary, just equidistant. We have something that is an equal distance between things. And actually I kind of want to double check what I put in for homework for this 3-6. Because the first example that I didn't have a chance to last class, I wanted to double check and see where we're at on this. So give me a second before we really get started. So I want to make sure that we cover maximum ground here. Actually might be quicker if I just pull it right up here. Okay, it's at 9 to 33. That's what I thought I did. Okay. Honestly, we're going to skip the first example just because we're not doing the constructions. Okay. But we know that the distance between a line and a point that's not on that line. So if I have a line like AB and I have a point, the shortest distance, the distance that I have between this point and this line is this perpendicular right here. Okay, so that's the main thing that you have to understand in order to figure out these distances. So we have this perpendicular postulate that says if I'm given a line and a point on the line, there's exactly one line from that point that's going to be perpendicular to the line. So if I have a line M and a point P, there's only one line that I can draw through that line, through that point, and crossing that line that's going to be perpendicular. If I try to draw any other line, it won't be perpendicular. Okay, so I'm going to skip over this just because, you know, all they do is they add in a couple points that are equidistant. We're just going to go through this quickly, but you have nothing like this on your homework. And they are doing these circles in order to work out another point to find this perpendicular. Now here is what's more important for you guys. And you may not be able to see this. That's really an X, point X in the center. Which segment represents the shortest distance from point A at the top to the line DB? The shortest distance is where it's perpendicular, right? So if we were to take a perpendicular from A, you come down and you reach X. So AX is your shortest distance.
Oh, okay. I was like, I don't know where you're getting X from, but okay.
X is in the center. It's where DB and AC are crossing.
Is that
Okay.
just assumed?
No,
Yeah.
it literally says X. Like there's an X here. It's just it's really faint.
Oh, okay.
Oh, cause I didn't
I was
understand
like-
what you were talking about. I was like, what?
There is a point X in there. I swear. You just can barely see it.
Oh, cause I seen X as an answer choice, and I was like, wait, is it assumed or what?
No, it's not assumed. It literally is there. If you were to see on my screen or something else, which is why I tried to, draw it in for you, but it's not assumed. It is physically there.
Okay.
There is that point. So
Will they always give you that point?
they should. Can I guarantee? Not necessarily. What they show is this. A, B, C, D, X. And so they say, well, what's the shortest distance from A to this DB? Well, that's A, X. So, unfortunately, the color of the kite did not make this easy on us. Okay? So now let's find a distance from a line to a point. Okay, what we want to do is we're going to be figuring out what line is perpendicular and determining the length of the line from here to here. Does that make sense? Now, I highly suggest that you guys literally take notes and make sure that you're understanding, because this is a multi-step process. And each step is easy to do, but to remember which steps you need to do is going to take a little bit of time. Okay? So we know that S has these 2 points, 0, 0, and negative 5, 5. And we know that we have this point that's not on the line at 1, 5. So we need to determine what this line is, and we have to calculate its distance, which goes back to chapter 1. So where do I begin?
I have a question.
Uh-huh.
So on the one where it's like negative 5 line, that one's like far out and you can like actually count to 5. But then on B, like how is that 5? Because
1, 5.
no,
I count over 1x up 5.
I'm just
I have those moments too.
I was so confused because like how is that one gonna go by 5 and that one gonna go by 1?
This one went over 5 this way, up 5. This one went over 1 this way, up 5. This one's at the origin, 0, 0. Okay? So the first thing that we're going to do is we're going to find the slope of this line. Do I know how to find the slope?
Mm-hmm.
Y2 subtract Y1, X2 subtract X1. And so the slope of line 1, or line S, we're going to keep track of that. Slope of S is negative 1.
Pictures yet, please do so at this time. Please go to the gym floor. Also, if you are a student who
Okay.
did not take pictures,
Now it says, now write the equation of this line using the point 0, 0.
take your picture for the first time.
Because we don't know what the equation of that line is, we just know 2
If
points.
you kind of do so, let
We
me
know
if
the
you need
slope.
coverage. Thank you.
Now you could do this one of 2 ways. My immediately thought was I have a point and a slope, so I was going to use the point slope formula. Okay? Because we can do this either as y subtract y1 is equal to m, x subtract x1, where I put in 1 point and the slope. They're going to do it a little bit different. Okay? And both ways work. we're just, do I go left or do I go right? You know, to make a couple turns to get to my location. It's kind of like GPS. Okay, they actually use the point slope intercept, the slope intercept form. They plug in the point and the slope to find out what the B is. And then they backtrack and put in y is equal to slope x plus intercept. So that's what they do. Okay, so that's one way to do it. That y is equal to negative x, because they said, well, y is equal to negative 1 x plus slope, b is 0. And that simplifies to that. Y is equal to negative x. If I did it this way instead, and I still use that point, I could say y subtract 0 is equal to the slope, which was negative 1, x subtract 0. Still get the same thing. Y is equal to negative x. It's going to depend on you. Doesn't matter which way we go to find the equation. The point slope form, slope intercept form, both work.
Okay, so when I first thought of it, I was like, okay, well, how are people gonna do slope intercept form? But
Because they,
literally,
yeah.
I understand the y-intercept is 0 because the x value is 0.
Yeah, and that's the thing. You don't even have to do this. You could have said, oh, well, x is 0, which means that is along the y-axis. So this is b. This is that y-intercept value right there. You could have just plugged that in that way too. It doesn't work though if this were a different value of x. Like it would still work if it was negative 1, 0. 0, negative 1. If that were the case, this would still be the y-intercept. If this was 0 and 10, that would still be the y-intercept. So you could have taken a shortcut of knowing that x is 0. Hey, I already have the y-intercept. But that only works if x is 0. Okay? So at this point, we have the equation of this line. That equation of line S is y is equal to negative x, period. Okay, y is equal to negative x. So we found the slope, we found the equation of the first line. Okay, so how am I going to write an equation of a line that's perpendicular to that? Do we know anything about perpendicular lines and slopes? Yeah, so far we have one that's negative 1. The other one is going to be this way, meaning at a right angle.
So
you
opposite reciprocal.
So the slope of, we'll say line T is equal to the opposite reciprocal. 1 over 1 is still 1. Change the sign. Slope is 1. That's kind of convenient. Okay, slope of line T is 1. So we can write the equation for this line using the point and that slope. They put it back in the slope intercept form because they want to find, even though we have this, the y-intercepts, like this is really our y-axis here. And we have these lines that are crossing, but where line S and where line T cross are going to be in two different locations. So now I need to find my new B. Okay, we found B for line S, now we need B for line T, okay, which should be lower down. So they plug in the point, the slope, the point. This is y, slope, x plus b. And we get b equaling 4. Okay, 4 is the intercept this time. It's actually going to be higher up. They're crossing in a different way than what I have in this picture. Okay. Do we know how they find this intercept? You comfortable with that? So now, with this, they go back to that y equals mx plus b. Y is equal to slope, which is 1, x plus b. So y is x plus 4. So equation of line t is y equals x plus 4. Now here's where it's going to go weird on you. That you were not expecting. We need to solve a system of equations so we can find out where do those two lines cross. We need to know if we have this line and this point, which makes this perpendicular, we want to know what is this point here, that point of intersection. So we need to take a system of equations, line S, line T, and we're adding them together so that we can get rid of the X. So we're adding them together this way, y plus y, 2y. Negative x plus x is 0. Plus, 0 plus 4, 4. And that means y, the y value of this particular point here is 2. Because we're finding, if I were to put these two lines together, where are they crossing? This gives us the y value. Okay, so solve for x. Well, we can take either of these equations, I guess. We can take this equation or we can take this equation. Okay? Let's take this and bring it down here. Y is 2 equals negative x. So if I solve for x, x is equal to negative 2. So now I have that point. I know the point where it intersects. I know the point that was already on its own. What was that point? Do we remember long ago? That was quite a while ago, huh? Let's go back. 1, 5. So this one is 1, 5. This one is negative 2, 2. Do you know what we do to finally determine the distance? Along those lines, use that distance formula.
Oh, I remember that.
Distance formula way back when. Distance equals x2 subtract x1 squared plus y2 subtract y1 squared. Take the full thing, square root. So when we do that, negative 2 subtract 1. 2 subtract 5. Okay? Negative 2 subtract 1, negative 3, square it. 1, 2 subtract 5, negative 3, square it is 9. So what we have is the square root of 18. Which means the length of this line from here to here is the square root of 18, or in your calculator, 4.24 units. So we went through these steps. We had to find the slope of the line that we had and the equation. And then we had to, from there, determine the slope of the perpendicular line and the equation. Okay? So, slope of line 1, equation of line 1. From there, slope of line 2, which is the inverse, and flip the sign. Equation of line 2. Oh, sorry, this should be step 3, step 4. Step 5 is the system of equations. So we can find the point of intersection. And once we have that point of intersection, our last step is to find the distance of this line using those 2 points in this formula. Tedious. Do you know how to do each step? Yeah. But it's slope, figure out the equation. Slope, figure out the equation. Okay, this one I need to know that that slope is going to be the reciprocal and switch the sign. Then I have to solve the system of equations to find out where do these 2 lines meet. So I have this point, so I have my 2 points to figure out the distance. Distance between parallel lines. Okay, the distance between 2 parallel lines is the perpendicular distance between one line and any point on the other line.
So are we gonna have to do 3, 6 at some point? The homework?
Yes. This will be due, I think I have it for Wednesday, so you still have tomorrow to ask some questions too. Okay. So when you think about it, I have 2 lines that are parallel, and I want to figure out the distance between this. If I take this line, that the perpendicular of any point on this line, if it's this, I drop a perpendicular, there's the distance. If I pick this point over here up, drop a perpendicular, there's the distance. Doesn't matter what point I pick, the distance between them is going to be that perpendicular distance. Okay. In a plane, if 2 lines are equidistant from a third line, okay, that's an equal distance. If those 2 lines are the same distance from a third line, then the 2 lines are parallel to one another. Okay? So here we're asked, find the distance between the parallel lines A and B, and they give us the equations. So we know the equation for A, and we know the equation for B. We have 2x plus 3, okay, and 2x minus 1. Do I know which ones are A and which one's B? They tell you from the language too, that A, then B, respectively. But could I also check for it? Yes. Y equals mx plus b. Here's my b, here's my b, b equaling 3, b equaling -1. Okay? So we need to find the distance between those two lines. So how am I going to figure out the distance of that perpendicular? Okay, you'll need to solve a system of equations to find the endpoints of a segment that is perpendicular to both A and B. Okay, from their equations, we already know that the slope of these two lines is 2. Y equals mx plus b. You might want to pay attention to some of this. No, not with your head down. Okay, it says sketch line P. That's this one right here. Why did they choose to draw this here? It was convenient because we already have a point right here. A very distinct point that was one of those y-intercepts. Okay, so they chose to go through 0, -1, because that was a known point. So what we need to do is figure out that other point. We want to know what that one is, right? So write the equation for line P. The slope of line P is the opposite reciprocal. So this one was for lines A and B. And so this is going to be the slope of line P, -1/2. Use the y-intercept as one of the points. In this case, they decided to go with the point slope form. I'll show you how this one works this way too. So what's going into this y1? -1. What's going into x1? 0. What's going in for the slope? -1/2. So they substituted in y subtract -1. Why do they have just +1/2? That makes no sense to me because they show here this. And I don't see how it's gone missing. There should be negative. Okay, y plus 1 is equal to -1/2 x. They show it there. I think somehow they just missed the negative in there. Okay, and when I take it one step further, y is equal to -1/2 x minus 1. So at this point we have the equation. We have one point. Step 2, we need to have a system of equations to determine the intersection between A and C. So what was our equation for A? Here's our equation for A. Here's our equation for P. Okay? How do we solve? Okay, it says substitute 2x plus 3 for the y. So in this case, they took this and they said, okay, we're going to replace this for the y, and they brought it in right here. So now we can solve for x. 2x, -1/2 x. Let's bring this 1/2 over here. This is gonna be 2 and 1/2 x is equal to subtract 3, They start grouping like things just like I did. So 5x is equal to -4, x is equal to -8/5. So that gives us the x of the point. We're trying to do this where we had known this one and we're trying to figure out the xy here. This one is -8/5. We need to know what the y is now. How am I gonna determine the y? I plug this x back in. Y is equal to -1/2 -8/3 minus 1. And when I do that, it simplifies out to -1/5. Now, do we remember what this point is? We have it on a previous slide. Okay, we're going to use that distance formula to go from 0, -1 to this -8/5, -1/5, or this 1.6.2. So I need to use the distance is equal to the square root of x2, x1 squared, y2 minus y1 squared, square root of everything. So you plug in all those points, and we get our distance. And we'll finish up tomorrow.